Hello, I'm Michael Wybrow, and in this video I'm going to give an introduction to Swift, talking about types, variables, collections, and optionals, and we'll go into more detail in the workshop, actually going through examples and looking at specifics of some of these. And if you have any particular questions, I would suggest that you kind of note them down and you can ask them as part of the workshop sessions. So, to start off, variables, variable declaration and primitive data types in Swift. The data types are similar to those in C, however they take on a slightly different format. So first thing is that Swift will try and automatically infer variable types. So if you just define a variable like var myInt and give it a value, Swift will assume that in this case this is an integer and it will be strongly typed. So Swift, at the Swift compiler, knows that anytime you use this variable myInt that it has the int type. Similarly, the same thing would happen for a double. Now, if you need to, and in some cases like in a function declaration, you might need to specify what the particular type is. And how we do that is we just specify the variable name and then give a colon and the type, list it after it. And in this case, you can initialize it in the same way, just with a literal following an equal symbol. So, Swift has a concept of constants. When we do var, we're creating a variable that can be modified. If we want a variable that is constant and can't be modified, and you should be doing this if there's something that you expect is never modified, and the compiler will warn you of this and suggest that you change it, you should be using let. So if we know something never changes, write let. In terms of the types, you can see we have ints, doubles, characters, strings, which we'll see in a moment, and booleans that are all the basic fundamental types in Swift. All right, so let's have a look at type conversion and also string concatenation. So Swift won't do automatic type conversion like languages like JavaScript will. If we want to convert between things, we need to explicitly do this. So here's a string where we've got just a string literal that says my age is, and if we want to have a string that has the age listed in it, we can say something like my string and just give a plus and take my age, which is an integer, and convert it into a string. Strings are also well supported in Swift, and if you need to construct strings, you can easily do them, build strings that already contain variables, which makes it a bit easier to do what we just saw in the previous example. So you can do something like write a summary here. We give a string literal, but if we want to include the value of a variable or another Swift expression inside this string, we can do that by doing backslash and then brackets, and inside we can give that expression, which in this case is just a variable name. And this is an example of using the sort of syntactic sugar of saying summary equals its current value plus a new string that you're concatenating onto the end, and this will output John has a total of 10 apples and Susan has 5 apples. As part of the workshop, I'll show you how you can take any of these small examples and we can just see the results of them in Swift very quickly using a Swift playground. So there are a couple of collection types that we will cover. Arrays look very similar to other languages like C, though arrays in Swift are mutable by default, and that is unless they are created as a constant. So you can think of them as being a bit more like array lists and vectors, array lists in Java and vectors in C++. So here's an example of an array literal. In this case, this will be an array of strings, but you can specify the type as well if you need to. And if we want to refer to a particular value, we do that using the square brackets and giving the index, and again this is 0 indexed like in C, so the first element would be index 0, apple, then pear, then banana. We can both use this notation to access a value in an array, but also to add a value into an array. So you can modify the third value here and change it to jackfruit. If you need an empty array, you can specify the type, which in this case is just a string in square brackets. That's the type name. And then we can initialize an empty string with, an empty array of strings with the, by just calling the empty constructor for this, or which in Swift is called an initializer. Array types also have a number of methods, and we'll have a look at some of these in the workshop that can do things like provide you the first or last element, or append a value, or insert a value. So there's lots of flexibility of things that you can do, and we'll have a bit of a look at the documentation and we can see how some of that works. Another really useful type, collection type in Swift, is a dictionary. These have the structure like dictionaries. They're a key value store. They have to have, each entry has a unique key and they're not ordered. So all of the keys in the dictionary must have the same data type, and all of the values must have the same data type, with some caveat that again we'll explore in the workshop, which is that Swift has a kind of any type where you can specify something that could be a string or an int or something else. So here's an example of a dictionary literal. The syntax for this is square brackets again, but each element has a key with a colon and a value, and you'll notice all of the keys are strings, all of the values are integers. So, I mean, implicitly, Swift will recognize that this is a dictionary of strings, string keys, and int values. If you want to explicitly specify the type, you can do it like this, where the type is square brackets, key, colon, value type. And if you need the empty dictionary literal, it's just square bracket, colon, square bracket. Now, you can access a particular value by giving the name of the variable, in this case people, and the key, Sarah, and we would expect the value 33. And we've done this by printing out a string. Now there's something we haven't seen yet here, which is this exclamation mark, and this syntax is for unwrapping a variable. Okay, so what is unwrapping? So one of the peculiarities in Swift that might be a bit different than some other languages you've seen is that we don't have pointers as such. In Swift, variables cannot be a null pointer or null or nil. This means that variables must be assigned a value when they're declared. But the way of dealing with this in Swift is we have what are called optionals, optional types. And optional types are denoted with a question mark. So here, this variable, maybe number, is an optional int. And what this means is that either this variable has no value, in which case it's nil, or it has an integer value. After this point, you can just work with it as a normal variable. So you can say maybe number equals 70, and we'll set an actual variable. And you can think of these optional variables as being a sort of container around the variable. So to get the data out, we need to unwrap it. So how do we do that? If we are certain that a variable contains a value, then we can force unwrap it. And we do that just using the exclamation mark syntax we saw on the previous slide. So in this case, you'd say, if maybe number is not nil, then we know it's not nil, it must have a value, and we can show that value. Having said that, this syntax where we use a force unwrap is dangerous. It's a bit like dereferencing a pointer in C or C++, and if you dereference a null pointer, you crash. And the same thing happens here. If you unwrap an optional value that's nil, all bets are off. The app just crashes. So I don't want to see this in your code, and you shouldn't really see this in any of my demo code that I show in the workshops. If I do, please point it out, and we'll talk about how we could write it in a better way. Very occasionally I might use it and just explain why I'm using it, but we should instead be doing things like optional binding. And here, Swift has a neat feature where we can have an if statement where we say if let some new variable equals the value of an optional variable. And what happens here is, like, you've got a variable, maybe number, that's an optional. We say let number equals this. And this if statement will succeed if the optional can be unwrapped, as in if it has a value. And then inside the code here of this, the true block of the if statement, we can just refer to that value, number. If it can't be unwrapped and something can't be assigned to number, then you get to the else block here and you can handle it in a different way. And we'll also talk in the workshop about, and you'll see in over the next couple of weeks, how we can use guard statements to structure code quite nicely for situations like this. So the type of this, because we don't specify one, is always the unwrapped type of the optional. Okay, thanks for watching. In the next video, I'll talk about some things like classes.